Well, Peter, the problem is I'm not going to be doing any judo today.
What? No judo? Oh, that's pretty disappointing. Why aren't you going to do any judo?
I wasn't able to find any volunteers who'd let me throw them around.
Well, what are you going to be able to do today?
Well, as Professor Sprott said, sports is all about physics and a certain point. It's dealing with forces and momentum and things like that, so I thought I'd break something. Anybody want to see me break boards? Now, since this is about physics, I'm not just going to break a board and have it at that. I have to explain how it works first. And to begin with, one of the important concepts is pressure. Now, we're all familiar with atmospheric pressure. That's the force of the atmosphere over the area of our bodies or any other object in the atmosphere. And that's about 15 pounds per square inch. I'm going to use these Magdeburg hemispheres here, and in a moment I'm going to ask for a volunteer. But before I do that, I'm going to take most of the air out of this, and you'll see that this dial will go down towards here. Now it would take forever for it to actually reach 0, but we'll go for what we can get. And that should be good enough. Now, as I said, the pressure of the atmosphere is approximately 15 pounds per square inch. And when I take most of the air out of here, that's how much force is going to keep these together. Now, I'd like a big, preferably brawny volunteer from the audience. No, someone big, maybe an adult. You, sir. I'm going to attach this handle here. Now, what do you think is going to happen? How many people think that when we pull on this, we're just going to be able to pull these apart? Raise your hand if you think that. Raise your hand if you think we're not going to be able to pull it apart. Raise your hand if you think we're going to fall over and trip over each other. Okay. Well, in physics and other sciences, we have to actually do the experiment. We can't just make a good guess. So if you would be so kind. And your name? Saul. Saul, thank you for being cooperative here. Go ahead. Now, what do you think is going to happen when I open this valve? So, what's the big deal about pressure with regards to breaking things? Well, pressure, as I said, is force over area, and when you narrow down the amount of area that you're applying the force over, you can increase the pressure. And that causes something to bend. And when you bend something too far, it can't recover its original shape, and it breaks. And I have this demonstration here, where I'll take this small piece of wood, and I'll use this hydraulic press. Now this has two cylinders, a small cylinder here and a large cylinder here, and there's oil in here. And when I push on this handle, it will apply pressure to this oil, which will go through this tube, and it will raise this piston here. Now you'll see that there's a triangular piece of metal here, and that will apply the force onto a very narrow point here, and that will bend the board and break it. And this idea of the pressure being transferred from one piston to another is due to Blaise Pascal, a very famous physicist and mathematician. And there you go.
That's how they jack up your car in the garage, isn't it?
That's correct. That's exactly how it works. And there you go. So that's what I'm going to do when my trusty assistant comes out with the boards. I'm going to hit this board right here, and I'm going to bend it enough to break it. Now, there's a way way that I can actually increase the striking power of a blow. And you'll see later on a demonstration of something called angular momentum. And in this case, what I'm going to be using is the angular momentum, which is the idea that something that's turning wants to continue to turn. And I'm going to use that to add to the force that I'm delivering. I'm going to snap my hip and break the next board.
Ouch, I don't think that's a sport for me. That looks like it'd be very hard on your knuckles.
Well, it can be, and you do need to know what you're doing to do this, so this isn't a really safe thing to do on your own. But, you know, anyways, I want to thank you for being a great audience, and thank you, Professor Sprott, for having me on.